So in this unit, we're going to be doing some analysis of the DefPoly program from section 1.5. Before we get started, I just want to mention that before you ever touch any of this code, you want to have a backup copy, of course, but also you want to test it out, make sure you understand what the requirements are, and test out the requirements before you make any changes, so that as you go, you can make sure you're not breaking anything as you do any refactoring. So the basic requirements for DefPoly are the first vertex is drawn as a tiny rectangle. Actually, let's step through them one at a time. So the first vertex is drawn as a tiny rectangle. So what does that mean? Okay, so let's click on here, and let's run this guy. Ooh. And we click on here, and we get a tiny rectangle. It actually shows up as a square. If a later vertex is inside the tiny rectangle, the drawing of one polygon is complete. So what does that mean exactly? Well, let's click a couple other places, and then if we click right inside this tiny rectangle, and you really do have to get right inside, then the polygon is complete. Well, what that means is if we click again, we start a new polygon. Okay, so that's all that means. And you do have to be really careful about getting right inside. But okay, so that's how we start a new polygon. What else? Okay, only vertices in the drawing rectangle are drawn. And actually, that one, let me see, where's our... that requirement isn't really met by the original one, because if I click out here, I can actually draw vertices outside the drawing rectangle. This is our drawing rectangle here, right? And that kind of makes things messy. So that's something we're going to have to address later on. So actually, that's something that's a requirement that's not being met that we're going to have to fix. What else? The drawing rectangle is either as high or as wide as the window, yet maintaining its height-width ratio regardless of the window shape. So the drawing rectangle is this rectangle right here, and you'll notice that this rectangle maintains its shape, keeps its aspect ratio, no matter what we do with the window. And when the user changes the shape of the window, the size of the drawn polygon changes in the same way as that of the drawing rectangle, as does the surrounding white space of the polygon. So let's make a polygon, and we can see as we change the shape of the window, as the drawing rectangle changes in size, the polygon changes in size, and the amount of white space around the polygon changes to scale. So we have a locked aspect ratio, right? So we're going to be doing isotropic mapping here. Let's see. Okay, so basically, yeah, so that's what you want to do. It's also a good idea to test border cases. Like, what if we click once and then click right inside that square? It looks like there's a tiny dot inside there, and yeah, as we'd like, we start a new polygon, right? So that's a border case. Another border case might be you make a line and then you go right back to that point. So we only have 2 points, and yeah, we start up a new polygon. Okay, so whatever border cases you can think of are good to test too. All right, so that's the first step is testing, and then that way every time you make changes, you repeat your tests and make sure that you haven't broken anything. And that'll be important as we move forward and start doing some refactoring to analyze this program.